Hello everyone, D. Alfred Ostrowski here. In this recording, I'm going to be continuing the 3-step demo tutorial on the fundraising application from the noted O'Reilly text, which I originally obtained it from on Ethereum programming from Kevin Solorio. So I demoed this application, or at least my version of it, in the day 12 demo. And here I'm going to be continuing on here as usual. I'm going to be going through examining the setup steps, which are in similar nature, if not exactly the same for the most part, of what I've done with the earlier tutorials in this series. I will be following my README file, the README install, and that's going to be documented with the associated GitHub, and that'll be posted with this video. In this recording, I'm going to be concentrating on just looking at the 2 smart contracts, and we're going to be invoking them from the command line, the Hardhat command line, as I usually like to, and then rolling some of those tests directly into some of the assertion testing. Now, you can go a little bit crazy with assertion testing and really make this extensive. I've cut it back a little bit for brevity. I think that a lot of the dynamics that I'm going to present here, you can easily see how you can expand it to perform more real-world testing, and also see how you could take this application and expand it in further ways, including the administration of the funds that are being transferred to suit more of a commercial usage. As usual, I'm on the C5 instance. I have it up and running. And as you see here, I have Hardhat running in the background in the similar fashion that I've always done it, and I have the Hardhat console, and I'm ready to cut and paste as I usually do. I packed a lot of information into the associated README install, and just gonna cut paste like I usually do and run through this step by step and look at the lines of code and explain it from that perspective. And then we're going to run it as an assertion test and set it up for the integration of the user interface. That'll be in the following video. Since I have the Hardhat console up and running already, I'm going to just bring up the smart contract directly from my GitHub and just run through that line by line so we have an example of the dynamics. And this particular application is unique that we're working with 2 Solidity smart contracts, and we haven't done that prior. And this suits the idea of one smart contract concentrating on, as I've explained in the prior video, that's hard to do the demonstration up front and a little bit more detailed because this is a little bit more of an involved example. That the first smart contract was going to just manage the single operations for an individual fundraiser, and then the second smart contract, which is being called the fundraiser factory, is going to allow that smart contract to be invoked, and then you can create and manage as many fundraisers as you want from a single page, similar nature that you would see with any of the related commercial applications. So let me just bring up those smart contracts and we can take a look at it, and then we're going to dive into the command line and roll in the assertion testing and explain everything line by line as usual. And this way you have the working components to experiment with your own variations and build your own assertion tests and applications. So here I'm going to just take a step back real quick, okay? And I have everything start to finish. This particular instance, I just brought it up today and reinstalled everything. Why am I doing this? Okay, why do I do this? So you can take my code and get it to work, okay? 99% of most demos that you see online, at least I do, okay, at least for me, if they're going beyond Hello World, or maybe in some cases just some of the initial Hello World style tutorials, they always fall short. Something doesn't work, some type of glitch or something. That's why I'm using Amazon, as I've explained before, and that's why I keep on going through these installs, that you can have a tractable demo example that you can run through in one sitting, and most importantly, get it up and running, and then break it down and understand how it's working line for line, and use it to fuel your own development, right? That's how you learn, right? Is taking small, concise examples and expanding on them, okay? So here I have, this is all the day zero code, hasn't changed, okay? I'm trying to keep everything as similar as possible. I use the create React app, and then within that did a Hardhat install. I have the Hardhat config. I put, don't forget your DNS. And if all this is not familiar to you, it might be in your best interest to look at the day 0 through day 11 recordings, and that'll bring you up to speed. Some of you don't need it, okay? Some of you are already familiar with the style that I'm presenting these examples, and that's great. So use it to whatever suits you best, right? So one thing I want to remind you, okay, make sure that you're in the project directory here. That's why I do the PWD and present the right directory, because if you do it in the wrong directory, obviously it's not going to work appropriately. I create the 2 smart contracts. I have that lock Solidity, that's with the basic install. I'm just deleting that. We can look at lock in more detail down the road, but again, just want to get this up and running. Here I even add the code for the front end. We're not going to be working with that in this video. That's for the next one. But I decided to combine the day 12, 13, 14 all together. That way I'm not maintaining 3 code bases for the same example. So here I put in the app.js and also created a components UI directory for the card JSX, and this allows for the card style functionality, and we'll cross that bridge when we come into it. But if you want to put it in a comprehensive fashion, you can take a look at this, or even if you just want to run through this video, you could skip through this step and you would be fine. Here I have a deployment script. Again, we're not using deployment because first of all, I don't need Hardhat to run the assertion testing. I don't need the Hardhat simulator to run. And from the command line, I'm going to deploy it by hand anyway. But I have the deployment script. And again, as I presented in the day 12 video, I got 2 versions of this program. I put a front end on the fundraiser, and then I put a front end on the factory that invokes the fundraiser. Here, I'm going to approach in a similar style. I'm going to invoke the fundraiser individually from the command line, and then we're going to invoke the factory individually, and the factory invokes the fundraiser, okay? And then we're going to roll this into the assertion testing, and just like before, step into this very lightly, and I think that you can see the consistency. So let's look at the code here. Here we are relying on OpenZeppelin. Happy that we installed that right on the first day because I wanted to keep these installations exactly the same. And the original example this program had, in my opinion, a more complicated than necessary API or interface to facilitate the understanding of the dynamics of this application. So for that reason, I omitted the material UI and redesigned the UI, and we'll cross that bridge when we come to it. But in any case, we're relying on the OpenZeppelin ownable and safe math. We don't leverage these to the highest extent in this particular example, but hopefully you can begin to get the appreciation of what they're doing for us, okay? What the ownable is going to allow us to, and you might want to look at, I'll try to include, I did a video, I believe in this series on the payable smart contract. So the ownable allows that contract to be managed and undergo a lot of the administrative activities that we could do by hand here, but I didn't roll into the application for brevity. But that's what ownable is allowing me to do, is to allow that contract to be managed externally, in particular with the transfer funds. And again, this is a lot of the dynamics that aren't inherent in other languages, right? that you would at first glance have a means of comparison against Solidity. You might say it look like Java or C++ or something like that. But here where you have a lot of behind the scenes support, in this case with the manage of allocation of funds, and that's where Ownable is leveraged without getting into too much detail. Safe math allows for operations that will support more improved power in the terms of exception handling. Could we get by this example without using safe math? We most likely could, but it's good to introduce it at this point and kind of keep it in mind how it's being used and leverage that towards future usage. I have a struct here for donation, and again, this is looking at it as an individual fundraiser, and each individual fundraiser will be managing a value of each donation and a date. So here we have it set up as a struct, and here we have a map pointing addresses to the donation. So we have an associated array that's allowing for the management of any number of donations. And you might have seen the dynamics in the smaller version of the UI that I presented in the day 12, where you had the history being shown up. Okay, so here we have events here, and we're not doing a lot with the management of events. Okay, again, I really reduce the UI to make it manageable and tractable. Okay, so we don't have to be going deep into it. And again, I think it facilitates better learning that way. But in any case, we're generating an event for a donation received with the donor and the value, and also one associated with draw. And I think that if you look at the earlier videos that I've done with event logging, you get an appreciation of the power and utility that can be allowed here. But in this particular example, in this 3-part series, we're not really leveraging it that much. Here I have public name, URL, image. I initialize them. These initializations aren't being leveraged because I'm passing in values. If I weren't, these would be default, and more about that as we get into the interface. Here I define a payable address to the beneficiary, and again, this is being managed with each individual fundraiser that's being generated. In this case, we're just looking at on an individual basis, but the beneficiary is who's going to allocate the funds, right? And the owner is the one that's going to be managing that allocation. Now, the beneficiary could be the owner, but in most cases, in a professional context, in most cases, you're not going to be both. You're going to have a beneficiary, and then you're going to have an owner or some external means of managing that. 2 more UNT 256, one for the total donations, pretty straightforward, and one for the donations count. We're going to see that in action as we bring up the console. The constructor, you're going to be passing in a name, URL, image URL, description, beneficiary, custodian. So as in these examples, I'm not using real URLs or image URLs. I actually passed in some images that are being served with the application, and interestingly, some of the URLs that are provided, and I'll provide the original book that I was inspired to do this example from, and the original image URLs that they provided actually work, and they don't work anymore because the book is out of date a little bit. So in any case, I'll get into a little more detail when we work through the React interface, which will be the next video, so you can keep that in mind. Here we're making the assignment, and interestingly, the underscore, if I haven't mentioned earlier, okay, that's making the designation between the parameter being passed in and the parameter that is internal to the smart contract. And really nothing else. There's not a lot of inherent power in that. Okay, so here I have a function to set the beneficiary, so we can change the beneficiary. Pretty straightforward, not a lot going on there. My donations length is going to take the associative array for donations, and it's going to retrieve the length of that data structure. Donate is a payable function, and it will include the donation that's being passed in as a structure of a value and a associated timestamp, and that'll be pushed to the donations data structure. Total donations will be added using the .add, and that's where safe math comes into place. Okay, so safe math is, in a sense, wrapping these values, allowing the use of add, and providing some higher level of protection from an exception handling perspective. Here I have count is assigned to my donations count. And here I have values and dates are assigned to the count incremented into that associated data structure. So looking at donations altogether, what's going on here is it's packing in all the donations and values, and it's going to return them in the singular data structure as provided here. Withdraw is going to take the associated value and transfer it to the address of the beneficiary. See, the beneficiary is here, and it's being set outside of this function. Receive funds is going to take the total donations and add the current value to it and increment the donations count respectively. So let's invoke it from the command line, and we can go back and look at the smart contract for the fundraiser factory and then roll it into assertion testing. So here, and again, I'm just flying through my examples here, and I've started up the Hardhat node in the background. I have the Hardhat personal blockchain also running as well. So here I have the console up here. So I'm just going to cut and paste these over and run it from. So I brought in the signers. You're going to know what that looks like. Here I'm going to do get contract factory, and I'm going to assign it. Now, don't confuse the contract factory with the fundraiser factory, right? So we know the difference are, because we've been using the get contract factory up to this point. Here I'm going to make some assignments to the values are going to be defined for an individual fundraiser, and I just kind of dummy these up. So I'm not really going to be doing anything specific with them. And the image URL in this case, again, is an actual URL, but it's not being used at this point or available. That's why I'm serving the images along with the application. Now, one thing I didn't cover is getting those images onto your EC2 instance. So I'm going to do a quick supplemental video. You're going to have to FTP it. You can't do it through PuTTY. So I'll make a separate video. If you're not familiar, maybe you are, maybe you aren't. It all depends on your background. Here I'm taking the signer accounts and assigning it to the owner and the beneficiary. I'm just grabbing those extra accounts of the 20 that we have when we bring up the Hardhat personal blockchain. Here I'm going to make the deploy, and I'm just going to call it fundraiser that I assign it to. And now I can pull the information out of it. And it's what you see, a few of the examples. You can hopefully have an appreciation how to do this with any number of other examples. I'm not going to run through all this, but I can go through the URL, the beneficiary description. I'll just jump out a little bit here just for brevity. And I'm going to just grab the last one, the owner, but you can see in the README file, I have all the associated information here. So I'm going to grab the donations count by doing my donations account. And I can print it to screen, and I haven't done any donations yet, so it's going to show up as 0. And this could be a start for assertion testing. I believe this is what I put in the first assertion test, getting a little bit ahead of myself. Now here, if I'm passing in values, I have to invoke the ethers library. I want to pass in ether into way. I'm not going to type in the 17 zeros and everything associated with that. And I do the donate. And again, just like with everything else, right? You can see the mechanics here of engaging with the program. And once we get into the actual assertion test, as well as with the user interface, you're going to have appreciation of how it all comes together because you've invoked a lot of the commands already. Here I'm going to just do a second set of values, and then we can have an appreciation how to retrieve my donations and how that format is coming together. So here I did a fractional of ether. Here I'm passing in a whole ETH, and I pass it into value 2, and I'm going to make a second donation. Again, just flying through my examples here, cut pasting here, but I just want to show you how to run this live. And again, you can take any variation and run with it. And maybe something doesn't work. What I like to do again is go back to the command line, test some things out, and get a more higher level of confidence. So here I have a second donations account, and I should have 2 because I did 2 already. And that shows up as 2. So here I can grab my donations, and that's passed in as a combination of values and dates. Now the values as shown is provided as a function, and I can actually, so I can take, values, but I take the dates, it'll actually pass the exact dates. If I don't pass it in at all, I can just take the await and it'll show the specific results. I did the first donation of the, should be what, 16 something odd zeros here, and the 0.289, and then the full 1 ETH. And here I have the associated dates with that. So there you have it. We tested the fundraiser by themselves, and now let's look at the factory. And then we're going to invoke the factory from the command line, and I intentionally canceled out of the Hardhat node in this case because I don't want to confuse the operations between the two. And interestingly, when you have the factory, you are not going to explicitly invoke the fundraiser. It's going to be managed inherently by the factory. So the factory Solidity file is going to invoke your individual fundraiser and keep on deploying more versions of it because you're going to be managing multiple versions. Let's take a look at the code of the factory here, and for convenience, I rolled all this into one huge README install. So you can see the relevant parts of the codes. You're not skipping through my project. But again, I backed up everything to the project so you can easily take it from the associated directories and reconstruct in the same fashion, or you can pull it down. Obviously, you'd have to install the appropriate software to run underneath, as I've done that, because Git is not going to provide that for you. So let's look at the factory here. Pragma Solidity, pretty standard. Here I'm doing import on fundraiser. This is going to allow me to manage that fundraiser individually from the fundraiser factory. So I have fundraiser factory defined here, and I have a max limit defined. Now I have an array of fundraisers, and this is going to include all the individually managed fundraiser contracts, okay, that are being executed, and the associated memory, okay. I have stored data, and then here I have an event being generated for the fundraiser created. And again, I don't have a lot of fancy frills in the user interface. But as you saw in prior examples, you want things to automatically update or manage the events and perform actions on that, and you can easily roll in a lot of that functionality. But again, to keep it simplified, I cut it down, and if you want to have an appreciation of how much more complicated it can be, you can look at the user interface that came with this originally, and it was 5 separate React.js files, and that brings us down the rabbit hole, if you will, of React and creates multiple learning curves. So I'm trying to reduce the learning curves of React, as well as Unix admin and just the overall admin of getting up and running by paring down these examples. First and foremost, get you up and running, start experimenting with the code, then you can get more extensive and more esoteric examples from that point. So here you have create fundraiser function, and it takes the same code or the same parameters, right, that I would use for an individual, and that invokes fundraiser just in a similar fashion to what I did before. Interestingly, sender is not being passed in. That's going to be invoked from message sender. And then when it's created, it's going to be pushed to the fundraiser structure end, generating the associated event. I'm maintaining a function to support the count, and that's simply the length of that data structure. So fundraisers takes a limit and an offset, and that's going to allow me to return a reference to all my fundraisers here, and that is accomplished by, again, reading in the limit and offset, and it's going to, as you see here, it returns the fundraiser. So you'll see this in action, okay, that we're going to return the data structure of all the instantiated fundraisers, okay. And I have a limit and offset. If you may be interested in just looking at a subset. Now the limit is essentially the length, and the offset is the point at which you might be interested in starting. So here we're going to perform a test. If the offset is less than or equal to the overall count of fundraisers, it's going to be set as out of bounds, and we're going to build an assertion test around that. The size is essentially the fundraiser count minus offset. So that gives you an idea. If I have an offset of 2 and I have 10 fundraisers, then it's going to return 8 starting from the given offset. So it's going to give me potentially a subset of all the fundraisers that have been allocated. And here we have some checks here with size. So size, if it's less than the limit, it is going to be set to the size, otherwise it's going to be set to the limit. And if it's less than the max limit, it's in turn also going to be set to the size if it is less. So we don't want to over-reference, right? You want to reference outside of the given list that's created, okay. And here we generate new fundraiser, and that is allocated to the associated size that's being given. So this is going to, and you notice that this is blank, right? So this is going to, and this is the fundraiser declaration, not the actual fundraisers. Fundraisers here, just as it's being defined with the column variable, is going to contain that offset plus that increment up to the length of that size. So if you think it out a little bit, it's a little bit confusing in the beginning. But if I have 5 that are allocated and I only want the last 3, I could then put 2. And then in this case, the size that's going to be returned is going to be defined as 3. And then I'm going to increment 3, 4, 5, or 2, 3, 2, 3, 4, I should say, because it's less than size, and it's going to return that in the associated data structure. Get fundraisers at is going to allow me to index in, and that's going to return a reference to an individual fundraiser, and a little bit trick with address that you have to allocate in this, because again, we're managing multiple smart contracts, and the factory is managing that fundraiser smart contract. So we have to interject a few extra lines here that we'll do from the console, allow you to reference individual attributes from a separate fundraiser that's been allocated from the factory. So we can go back to the console now, and I'm just going to continue on with the example here and run through it line by line. So here, again, I'm going to start this up. So the console, and I want a fresh start because I don't want any confusion between the last example and the current example between the demonstration here. So I pull my signers. I'm going to assign the associated information for the name, URL, image URL. Kind of do this in quick fashion. It's pretty straightforward, okay? And this is taking it directly from the associated documentation that you'll have reference to as usual. And this looks exactly like the last example, but the exception is I'm going to be managing this from the factory contract and not just the fundraiser contract. So you could almost consider this as a wrapper, right? So here I'm going to grab the contract. In this case, I'm grabbing the second contract. Whoops. Back this up. So I grab the factory contract, I put in a contract 2, and I'm going to do the deployment, and you'll note that from the command line, we're not going to be pulling in the fundraiser contract. So you're pulling beneficiary, and now I'm going to create a fundraiser, and I'm going to pass it into fundraisers 1. Now I'm going to invoke the factory, and I'm going to ask the factory, well, how many fundraisers do we have? And it'll return the 1. Okay. I don't want to reference fundraisers. 1 is not going to know how many fundraisers have been created, right? So now I'm going to grab the individual fundraiser at 0 index. So I get fundraiser at 0, and I get the associated address. Now, an extra step, I have to take the associated contract definition, ABI type information for the individual fundraiser, and that's being passed in. If you note, I'm not deploying that fundraiser. I'm just taking the factory and pulling that in, and you can dump that to the screen and take a quick look at exactly what it is. We've done that in the past. Just want to keep things moving here. So now I attach the address from the 2 lines before from the fundraiser address, and I pass it into single fundraiser. And now I can grab the individual attributes or any of the attributes. And I could also do, If I can do this, I can do the donate and the read the beneficiary and read the donations on an individual basis. And I can also set this up for, hey, allocate 3 smart contracts, allocate an amount to 2 of them, do some more donations to another one, and I can do the test. The testing can go on and on and on here just to show you some of the dynamics from the command line. And again, the hardest part here is understanding that I have to pull in that fundraiser. I'm not going to deploy it. Here I'm going to attach that address to that garden variety definition, right? And now I have the individual fundraiser, and then I can access that appropriately. Now let's do the assertion testing. I'm just going to run it, and then we're going to dive into assertion test, and then we'll be done. We're going to start looking at the user interface. So I'm going to do an npx hardhat test. Got to spell it right. That will always, that's why I do cut paste. I'm a terrible typist. So I do have some dynamics coming out at the end here, but all my tests pass. I've been getting these extra diagnostics, if you will. And if I'm not exactly sure why that's happening, but it's not an error. So we can take a deeper look at that at a later point in time. But the most important thing, I have a set of tests and they all pass, and we can dive into that, which is just a variation of what we just did with the command line. I just want to show you that they ran appropriately, and let's go into that test. And again, this is under test as usual, and I put it at FF.js. And let's look at the separate tests here. So I'm not going to go through all the dynamics involved here because we've gone through assertion testing, but again, this is a part of all of our development, and I'm cutting it down. You could do a lot more, but I think looking at this, you can have an idea of where to go with this. And I'm already at 37 minutes with this video, so I don't want to go too long with it. But I think once you see these examples, you know how to extend this. Okay, so here I use the describe, and again, describe is nothing more than a self-documenting function, and as such, it's not defined as asynchronous. It just runs independently. Here I have some variables defined, and we'll be using that as we move forward. Run every time, and the add fundraisers are a couple of external functions that are common operations. I'm going to be using assertion tests. So to avoid the repetition, I just rolled that into the asynchronous function. And you could put in before each or experiment between the two, run every time. I just invoke it explicitly and it runs in appropriate fashion, right? So here I grab the get signers, and we just did this from the command line, right? I do the contract factory, I grab the fundraiser, and I do the deployment, and here I roll everything together. So I'm not testing the fundraisers individually, I'm testing out from the fundraiser factory, because ultimately that would, in most if not all, be the suitable application or the more demonstrative application that you'd want to use. Fundraiser factory does the deployment, waits for it, and then returns the associated value. Add fundraisers, this creates a number of fundraisers. You note I put in the dummy variables here, just increments it with I, and it passes a name, and with the associated URL, image URL, here I have a PNG, the associated description, and I just take the name and attach on the numeric to create some variation here. And you'll see the output as we run it. And then we include the associated beneficiary, which is read from the get signers that you have up here. So these two operations, for the most part, are being run in every particular example. Here, the first describe, it tests for 0 fundraisers. And here I have the actual it test, and or maybe a little bit better. And here it has tests that I did from the command line, right? Just rolling it into assertion testing. We do the deployment of fundraiser and load in the associated fixture for the factory. And then we do the associated deployment, and then we do the test for the fundraisers count to equal. So, and this was extraneous to fundraiser off, so that I'll just remove that for the final copy. So all we need is the load fixture. Whoops, I'll delete this line as well. And I'll pull this out now just for, we can rerun it again, but we didn't need that deploy contract, right? So because I rolled that into the run every time with the load fixture. So we have run every time being run here. Fundraiser count sent to 0. I do an add fundraiser, and I pass in the factory and the associated count. And then we call fundraiser with the fundraisers 10 and 0. So I want a 0 offset, no reason to run the offset. Of course, if you wanted to explore some variations, that'll set you up for that. And then we're going to take the fundraisers count, check that to be 0 again. Next example is testing the collection to whether it's empty. So I do the run every time example again. I pass in the fundraisers count. I do the add fundraisers. And check that for 10. Here I invoke the fundraiser factory again, and I pull in the fundraisers with 1 and 0 as the parameters, and I check the length equal to 1, and I grab the first fundraiser, so that's 0 index, and here I do the attach as I did before, and I'm going to check that, and it started from 0, and I can read the name and test that and set up the appropriate test. Next example with the offset. So I'm going to do a test on the appropriate offset, do a load fixture run every time, add the fundraisers. I got the fundraiser, in this case, at 7. Because I set the fundraisers. And let's go back up to add fundraiser again, just for context. So add fundraiser is calling create fundraiser all this number of times, right? So that will allow me to have a number of fundraisers that are created, and I can test against that. Here I perform a test of the offset, where I can pull back a subset of the factory offset to any number, provided that's given within the appropriate length. And here I have and test for that offset, right? So is the offset outside of the length that I'm interested in? And if it is, then it's going to flag it. But here I have a to be reverted with operation, and that's going to allow me to perform the necessary tests, right? That I can go back and get a positive test because I'm expecting an error in this case. So here, let me rerun this again just to make sure that that last example didn't upset anything. And we can see again that it ran in the appropriate fashion. And I got the 5 passing. Okay, so, and these are some of the variables I dumped directly to the screen using the console log. So there you have it. We took the individual fundraiser and the factory that invoked the fundraiser and manipulated both from the command line, and then we rolled these tests into our bare bones assertion testing. Of course, you can go nuts with assertion testing and do a lot of donations, and if you can test the name, we can invoke the donations in the similar fashion. Okay, reading in the contract definition, and most importantly, relying on the ability to attach the fundraiser address to it and returning it appropriately. So in the next recording, we're going to look at the user interface that I presented in the last video, one for the single fundraiser and the second for the factory. So thanks for listening. See you on the next recording. Okay, bye now.